But yeah, thanks for coming. Hi everyone, my name's David French. I'm going to be speaking about detection as code in this session, which is a methodology that uses code and automation to manage detection content in security tools. The reason I used the phrase from soup to nuts, from start to finish in this title is I want this to serve as kind of a lasting reference for people who need an introduction to detection as code and need a practical example of kind of how to build it and implement it. So it's not just theory, we're going to show you how to build something here. So a little bit about me before we get started. I've been in IT and cybersecurity for about 18 years now. During the last 8 years or so, I've kind of gone back and forth between defensive practitioner roles, SOC analyst, threat hunter, that kind of thing, and working on the vendor side, developing detection content, doing detection engineering, and building kind of SIM and EDR products. Currently work at Google Cloud on the adoption engineering team. I work on Google SecOps, just recently renamed from Chronicle. And presented research at a few conferences, created a tool called Dorothy that blue teams can use to kind of simulate attacker behavior in their Okta environment, test their monitoring and detection, that kind of thing. And I've been living in America for the last 8 years, and a couple of Irishmen last night told me I had a funny accent, so apologies for that. All right, so when I think about who can benefit from this presentation, I think anyone who's kind of curious about what detection as code is, how to get started, maybe you're a defensive practitioner working as like a SOC analyst or an aspiring detection engineer, maybe you're familiar with managing detection rules in your security tools manually and you're interested in kind of automating some of that. If you're already an expert in this, you might not learn a ton, but if you've got experience in this, I'd love to chat to you later. Just out of curiosity, who's written a detection rule in a security tool before? Cool. That's a good number. All right, so here's an overview of what I'm going to be covering. So I'll start by providing a definition of what detection as code is and how it relates to those traditional methods of managing your detection content. I'll walk through an example workflow for a security team that's developing and managing their rules as code. We'll talk about the benefits of this approach, and then we're going to design and build our pipeline. And then, I'll leave you with kind of some lessons learned from implementing this at a few companies, some links to useful resources that you can use to build this with whatever tools you have, even if it's in your lab or where you've got to work already today. All right, so here's my definition for what detection as code is. I like to think of this set of principles that use code and automation to kind of implement and manage that threat detection content in your tools. So when we think of the traditional approach for managing our rules is to kind of log into your SIM, EDR, firewalls, and you're kind of manually configuring those rules and signatures, right? And then with detection as code, we're kind of leveraging these DevOps kind of software development practices that have been around for a while, using CI/CD tools and kind of automation. So this has kind of been gaining in popularity the last 4 to 5 years. And if you're new to this, I've included some links here. I can share the slides later to existing work, right? Stuff that's inspired me as I've worked on this at a few companies. So just to acknowledge, everyone's got varying levels of experience with detection engineering, writing code, using some of the software development tools I'm going to talk about. So here's some kind of basic nomenclature or introduction to the core technologies we're going to use to build this pipeline, right? So starting on the left, that's the left, yep. We're going to need a version control system software, so you've probably heard of Git. This is going to track changes to our code over time, allow us to make kind of incremental changes, rollbacks, have that version history, that kind of thing. And then we're going to need a software development platform. You've probably heard of like GitHub or GitLab. This is going to provide that centralized workspace for us to manage a repo that contains our code, right, our detection content. So when an engineer wants to make a change to detection rules, they can create a pull request and stage their changes and ask their peers to kind of review and approve that. And then we're going to need a CI/CD tool. Examples here, you've probably heard of GitHub Actions or GitLab CI/CD pipelines. And what this is going to do when the code base for our detection rules changes, we're going to have a tool that recognizes that change has happened, and then it automates the kind of testing and deployment of our rules to our security tools. So here we've got an example workflow that a security team can use to manage detection rules in their SIEM. Just as an example, using GitLab or GitHub. I'm going to be using GitLab for this project. That's what I had access to at the time I built this. So yeah, as with most things, this is a way of doing it, or B ways. You can kind of customize it to fit your needs. But yeah, starting on the left, we've got a detection engineer who wants to make a change to detection rules. Maybe they want to create a new one or update an existing one. So what they'll do is they'll create a new branch in the GitLab project and stage their changes in a pull request, right? So they might create a new rule and kind of stage those changes. And then after that pull request is created, we've got a set of tests that are executed by our GitLab CI/CD pipeline job. These tests are going to check for things like rule configuration issues or problems with the syntax of the rule's logic, and that the rule actually still matches on the intended behavior. And then once those tests passed, they get a peer to kind of review those proposed changes, and this is where the security teams kind of discuss those changes, provide feedback, suggestions on the rule, and that kind of thing. And then after the engineer's pull request is approved, they can merge their changes into that main branch of the GitLab project. Our CI/CD tool is going to detect that changes have been made to our code base, and then it's going to push those changes out to our SIEMs API. All right, so that's kind of hopefully giving you a basic understanding of detection as code and what it is, if you're not familiar with it. And we can move on to talk about some of the benefits before we go ahead and build this thing. So first benefit, I think, of working in this way is this collaboration, right? So one of the challenges managing detection rules manually in security tools is that people can log in. I'm sure we've seen this, right? Log into a security tool, make a change to a rule without any input from anyone else on the team. And, the team might not have approved that change, or people make mistakes, right? We've probably seen a rule that's been changed and it introduces an explosion of false positives or false negatives, right? Missing attacker behavior. But when you're working in this kind of collaborative approach, in my opinion, you've got people with different skill sets and expertise on the team. It's going to lead to more effective rules. And then, continuing on the subject of collaboration, managing your content as code makes it easier to kind of share that content with the community. So I used to work at Elastic back in 2020, and I think they were one of the first kind of big security vendors that opened up all of their detection logic. We started doing all of our detection engineering out in the open, started accepting community contributions. And then, during the last 4 years, you've seen all these other players kind of follow suit, right? People might argue that makes kind of your defenses weaker, but when you're talking about hundreds of detection rules, the attackers walking across this minefield, right, they're not going to be able to evade every single one of them. And then next, working in this way kind of gives you more control over changes that are made to your detection content. So when you store them in your software development platform, you can make sure that your rules are or any changes are tested, reviewed, and approved before they're pushed out. And in this screenshot, you can see, the engineer's proposed changes can't be merged into the main branch and pushed out to the security tool because their tests have failed, right, in that CI/CD pipeline. Some organizations require this level of control over their detection rules as well as their preventative controls. We're not just writing detection rules for fun, right? They're security controls that we need to look after. And then final benefit here may be obvious, right? We're borrowing these DevOps-style software development practices, CI/CD tools. We can build this pipeline to kind of automate that build-in, testing, deployment of our rules. Obvious benefit here is to the time it saves us, and then you can have a set of tests that trigger your rules and validate that alerts were generated, right? This test that you're kind of logging, monitoring, detection pipeline is working, and we'll talk more about that soon. All right, so that's the introductory theory covered. We can move on to kind of designing and building this pipeline. So simple design for this pipeline we're going to build for managing detection rules in our SIEM. So on the left, we've got our software development platform, GitLab. This project's going to be used to store our rules, which is where we'll be working on our rules as detection engineers. Rule logic is going to be in individual files in this rules directory. In the other directories, we've got some Python modules we're going to use to manage rules via the SIMS API. And then in the middle here, we're going to configure a few CI/CD pipeline jobs in GitLab. One of them is going to be responsible for running our tests for our rules. The other two are going to retrieve rules from the SIM and push rule changes out to the SIM. Some organizations might have kind of separate dev and prod instance for their SIM. They might test and deploy changes to their dev instance before they push them out to production. In this example, we're just going to have a single SIM, right? So on the right-hand side, we've got our SIM. It's got an API that lets us programmatically create, update, verify rules using code. So on the right here, I'm using Google SecOps in this project. That's what I had access to at the time I built this. If you're interested, I've got a blog series and some example code. One shows you how to do it in SecOps. One shows you how to do it using free, open source, and community editions of software, including, that one works with Sumo Logic. And I can share the links to that later on. So for the purposes of this project, we're going to presume a few things are true at this point. We've got a collection of rules in our SIM already. Maybe our security team configured those, or maybe the vendor put that initial collection there for us. The SIM's got an API that lets us manage rules programmatically. And then some vendors will give you example code for managing rules via its API. Sometimes you have to kind of read the docs and write that code yourself. And then, just a note on what you can do in the UI of a security tool versus the API. Users have become to expect that parity versus what you can do in the UI of the API, right? So if you work for a security vendor, people are going to be evaluating and scoring you on that. All right, so next step for this project, I like to kind of wrap those Python modules up that you saw on a previous slide into like a simple command line interface tool. And what this is going to do is just going to make it super easy for me to execute those commands in my CI/CD pipeline jobs for managing my rules, right? So I've got an example command to kind of retrieve rules via the SIMS API, do things like dump them to local files, and update rules and verify the syntax of rules. So for this project, I've written code to manage rules using the SIMS REST API. As an alternative, you might see security teams use these infrastructure as code tools that have been around for a while. Terraform, I guess Pulumi is a bit of a newer one. And then with this approach, you're still going to be storing your code in a central repo in GitHub or GitLab. Just to point this out as like a popular method you might see as kind of mature security operations teams want to manage everything as code, right? No matter what it is, whether it's rules or documentation or whatever. So I've got a link here to a blog if you're interested. This example uses Terraform to apply those changes to Sumo Logic. So if you're kind of considering implementing this, here are a few things to think about. So if you are managing your detection rules and configuration for your security tools as code, do you want to prevent those changes from being made in the UI of the security tools, right? Do you want to disable that? Some teams are small enough where they just can agree that changes should go through their code base and get pushed out to the security tools. Some people will disable that, right? Some people will have their CI/CD pipeline kind of apply those changes to their security tools maybe daily, in case any changes were made in the UI, and it will just override those. If you do end up disabling this, think about whether you want a detection to alert on that behavior, right? If people shouldn't be messing around in the UI, you can alert on that and figure out why. All right, so here's a layout of our GitLab project. So starting at the top, we've got those modules for managing rules via the SIMS API. We've got our command line interface that you saw earlier for executing commands to manage rules in our tools. And each detection rule is stored in its own file in this rules directory. This GitLab CI.yaml file stores the configuration for those GitLab CI/CD pipeline jobs. And then this file at the bottom contains the configuration for our rules. And this is where we're going to specify whether each rule should be enabled, disabled. It also stores metadata about each rule, like unique IDs, creation timestamps, that kind of thing. All right, so let's take a look at the importance and benefits of defining a schema for your detection rules if you're managing them as code. So a simple schema like the one you've got on the right here provides a way for you to kind of structure and standardize your rules. This is important if you've got a bunch of people working on rules, using different formats and schemas. You're going to find it incredibly difficult to kind of test and manage them, especially using automation, right? So this makes it more organized and easier to read. And then once you've defined your schema, you can have your tests kind of detect rule issues early on and prevent them from being deployed out to your security tools if there are any issues. And it also makes it easier to share detection rules with other people in the community, right? If you're using a similar format or the same format that everyone understands. So the example schema on the right-hand side here, this uses Pydantic, which is a Python library. And in this example, you've got a set of field names defined for your rule, the expected data type for each field, and whether each field is kind of required or optional. And yeah, here are a couple of file formats that people use for their rules. So Splunk and Sigma both use YAML. Elastic uses TOML for their kind of open source detection rules content. And both of these file formats kind of provide that human readability. Reading and writing these file formats is widely supported by programming languages. TOML's nice. It kind of lets you break your rule up into sections. So you might have a section for the rule's metadata, the rule's logic, and then maybe another section for like MITRE ATT&CK technique annotation. For this project, I've decided to kind of keep my rules in a separate directory and the rule config in that config file that we're going to see in a sec. And this is going to give me more granular control over where my rules are kind of deployed out, right? Maybe I'm managing rules in multiple SIEM instances if I work for a vendor or an MSSP. All right, so yeah, the benefit of having a schema, or one of them, is you can kind of validate your rules against it and catch issues early on. And then you can minimize the risk of deploying like broken changes out to your security tools. So in this example, we're using Pydantic. This is raising a validation error. We've got an invalid value or type that's provided for a rule field. And yeah, there's some low-hanging fruit you can take care of at this stage. You can check that, raise an error for missing values, rule configuration issues. You can't have a rule that's enabled and archived at the same time, and that kind of thing. And then once you've taken care of the basics, you can use either Pydantic or Marshmallow as another kind of data validation tool that lets you kind of create your own more advanced like validation use cases, right? Like checking MITRE ATT&CK technique actually matches the technique name or the URL. All right, so almost done with kind of the schema type of stuff. The next thing you're going to want to do is also verify the syntax of your rules whenever changes are being worked on. So some SIEMs will have an API method you can call to verify the syntax of a rule and make sure it is in fact like a valid rule object. If your security tool doesn't accept that or it doesn't provide that, you can create your own kind of linter to check that rule parsing and validation. And a linter is kind of like a grammar checker for your code, right? If you haven't come across that before. That will obviously take more effort. As the vendor kind of changes their detection engine and rule language, you'll need to keep up with that. So yeah, a bit more effort. All right, so yeah, next logical step for this project, we've got our kind of initial GitLab project set up. We can pull the existing rules from our SIEM and commit them back to our code base. So to help with this, we're going to use that handy CLI. And what this does, it pulls the latest rules from my SIEM and writes them out to local files. And it also dumps the rule configuration to that rule config file that we saw, or that we're going to see next. All right, so here's what it looks like when the latest rules from our SIEM are pulled and kind of written them out to our rule schema and written them out to our respective files. So on the left, we've got our YARA-L rules in this case that are written to those individual files in the rules directory. And then on the right, you can see the configuration and metadata for each rule is written out to this rule config YAML file. So for this example, you've got separate schemas for the rules and the entries in that rule config file. And this lets you catch any issues when the rules are kind of loaded from disk and before they're written to disk. So as you can see on the right-hand side there, each entry for that rule config, or each entry for a rule in that rule config file specifies whether a rule should be disabled or not. It's got the metadata for each rule, like the unique ID, creation times, that kind of thing. All right, so we looked at that kind of pull latest rules command. What we've got here is our first GitLab CI/CD pipeline job that automates the process of kind of pulling those detection rules from the SIEM and then committing any changes to our code base, right? So you could run this nightly if people were still updating stuff in your SIEM. But in this example, we're saying people have to go through our code base to update rules. So I'm just going to run this job once, pulls the latest rules from the SIEM, dumps them out to those local files. And then in the output of this job on the right, you can see it runs the git status command to check if there are any changes that need to be committed to GitLab. And if there are any changes in kind of pending, the job takes care of that and commits into the main branch, which is what you see here, right? So this is what that initial commit looks like in our GitLab project. So our CI/CD job, all the rules that are currently in our SIEM. On the left, you can see the configuration and metadata was written out to that rule config file. On the right, you've got an example of a YARA-L rule being written to its own file in the rules directory. And then all changes were committed to the GitLab project by the CI/CD job. And then at the bottom here, you can see that git commit message associated with those changes. All right, so now we've got our kind of SIEM and GitLab project in sync, right, with our detection content. Going back to our detection engineering workflow earlier, this is how an engineer can kind of create a new rule, right, going through this detection as code workflow. So on the left, you can see a new YARA-L rule that detects a certain behavior in an Okta organization. The rule contains some metadata about what behavior is being detected and the actual rule logic. And then on the right, we're creating a new entry in this rule config file. We're specifying that the rule should be enabled to run over our logs and it should fire alerts when it matches on the intended behavior. So yeah, just a side note on this rule. This rule detects when Okta admin privileges are assigned out to a non-admin user account. So in this example, an account that doesn't start with the word admin. So if your organization uses Okta and has a set naming convention for admin user accounts, this is a good rule for you to have in place. So I used to work at an organization where we had this Okta admin that would assign admin permissions to another account, log into that account and carry out certain actions, then log out and remove those permissions. That was an insider risk case. Didn't end well for them. But yeah, just to let you know, I mean, this is a good rule to have. It can detect an attacker that's compromising admin and is assigning admin permissions out to try and maintain additional, methods of persistence. All right, so yeah, next step, when you're implementing this capability, it's going to be crucial for you to kind of protect the main branch of your project in the software development platform you're using. So in this example, I've configured protection rules so people can't merge any changes into that main branch unless the test pass in the CI/CD pipeline. We've also got a rule where I need to get peer approval from a teammate, and you can set that number to whatever you want. So the bottom image here shows that rule verification succeeded for 9 rules, but failed for one of them. The rule contains an invalid field name, and the engineer is going to need to fix that so the test pass, and then they can request that peer review. All right, so yeah, lessons learned from, when a detection engineer stages their proposed changes and asks their teammate to review their code. So after implementing this at a few companies, I think, acknowledging that detection engineering is hard, you've got to do that. It takes a lot of time and effort. You've got to do threat research to understand attacker techniques. Maybe you'll configure your lab environment to simulate attacker behavior. Maybe you'll generate those events to analyze. Then you kind of write your detection logic, develop your tests. So as that takes a lot of time and effort, right, and then you stage your changes, it's on display for your peers to kind of criticize and pick apart and challenge. So I think as rule authors, it's important to try and, assume positive intent. We're trying to make the best rules possible and try and avoid kind of getting defensive. And then as the author, as a kind of reviewer, if you think a rule sucks, don't say that. Explain, your thought process. Maybe the person who wrote the rule is an endpoint security expert and you're a network engineer background, that kind of thing. Provide that constructive feedback, try and get to reviews in a timely manner. So this quote from this book on the right-hand side has stuck with me over the years when it talks about code reviews. Don't be the reason improvements wither on the vine. It means kind of As a reviewer, insist on quality, but don't become this impassable barrier. Help people get their code merged. Don't expand the scope of like the change that's being proposed. Don't let disagreements fester. So yeah, it's got some really good points. Highly recommend that if you're kind of new to this stuff. And then yeah, finally, develop a rule style guide, right? So that people can understand the expected, minimum expectations and layout and format of a rule. And then yeah, that will result in kind of less conflict and arguments during this stage. All right, so testing rules. In the field of detection engineering, this is kind of a broad and deep topic. I'm going to try and cover some of the most kind of important parts before we can move on to show you how we can test the rule in our CI/CD pipeline and validate that alerts were generated. So yeah, when you're building this out, don't skip this step, right? If you're not testing your rules on a regular basis, then you can't have confidence that your kind of logging, detection and alerting pipeline is working properly, right? And it's only a matter of time before you get blindsided by missing a red team activity or attacker behavior, right? So if you've got 10 detection rules, you can probably keep up with testing those manually once a week or once a day. When you're talking about hundreds, it's not scalable. So yeah, a couple of challenges or considerations with regards to testing, or why people tend to skip this step. So I don't know if you've ever written a detection rule and then tried to write a test for it. Often writing the test takes longer than writing the detection rule itself, right? So people might tend to skip that. You might not have the expertise on your team to kind of develop and automate tests. So you look to hire someone with expertise, or do you look at an off-the-shelf tool that performs testing and validation for your detections on a regular basis? And then, yeah, final consideration here really, your team might start building out their library of detections and not developing tests, thinking I'll get to it one day. But, when that collection grows to over hundreds of rules, it takes a lot of time to go back and kind of write those tests, right? I don't know if anyone will get excited about that. I certainly wouldn't. Right, so yeah, some reasons why I think people need to care about this stage. Our environments tend to drift over time, so technologies, entire networks come and go. New preventive security controls rolled out. Are you trying to detect a threat to a technology that doesn't even exist anymore in the organization? Login interruptions occur. So if you have a rule that's running, it's never being fed any logs, it's never going to fire, right? Attack techniques lose their relevancy, right? Systems are patched. Every detection rule kind of has a shelf life. Pesky vendors kind of change their logging schemas, right? You've got a rule that's relying on this specific field name and a value in it. The vendor rolls out an update, changes the field name, your rule's never going to fire. So yeah, all these things really, or most of them, can result in false negatives, missed opportunities to detect threats early on before they become an incident. All right, so yeah, a couple of options for testing your rules at this phase. One option is to kind of ship test or synthetic events to your SIM for ingestion and then validate that your rules generate alerts. So this is better than having no tests at all, but it's not kind of comprehensive, validating that your logging, detection, alerting pipelines working end to end. In this case, what I've seen people do, they're shipping events that they've collected at an earlier time, right? Maybe when they were developing the rule, they're shipping those to their SIM. So that won't kind of validate that your rule's still firing on a vendor's updated schema, just as an example. So the more comprehensive approach here is to run, you've got a set of tests that trigger your rules on a regular basis. It validates that all components of your kind of monitoring and detection is working, and it gives you the opportunity to jump in and fix those issues early on before you miss behavior. If you're new to this, a couple of projects for you to check out. You've got Atomic Red Team by Red Canary and Red Team Automation by Elastic. So I think aiming for 100% coverage and testing your rules is, you'll kill yourself trying to do it, right? So if you've got rules that have machine learning techniques to detect anomaly detection or anomalies, it's going to be hard to write tests for that, right? If you're relying on a baseline and anomalies in that. So yeah, you can't test everything, and that's okay. So moving on, looking at a practical example of how to test the rule we created earlier. So in this example, I've written code that uses Okta's API to carry out certain actions that trigger the rule we saw earlier. So first it creates a new Okta user account that doesn't start with admin. It assigns that administrator role to the new account, and then it deactivates and deletes the user account. So we can configure our CI/CD pipeline to run tests like this on a schedule or when changes are being proposed to our rules. In the real world, right, you're not going to be able to run this test in your production instance of Okta. So you might have a dev instance where you're shipping those logs to your SIEM, creating a user account, assigning admin permissions, and then kind of throwing it away. You don't want to, there are probably approval processes in your production environment, right? You can't just assign permissions out, yeah. And if the test fails, you don't want to leave those permissions kind of dangling. All right, so we've executed our tests, and then we need to validate alerts were generated by our detection rules. So here's an example where I'm validating an alert was generated by that Okta rule. You can check that the alert contains specific indicators from your test, like the Okta username we used to create that user and then delete it. And then if alerts are being opened in your ticketing queue or whatever system you use, you can just close those out and label them as tests. So in this example, the tests passed, but if they failed, you can raise an error for the team to investigate and not kind of let them move to that next stage of pushing the changes out. All right, so now our tests have passed and our teammates have approved that pull request. It's time to merge those changes into that main branch of the GitLab project, which is protected. So when those changes are merged into main, our third CI/CD job is kicked off, and then it updates the rules in our SIEM based on the code that's in our GitLab project, right? So this job is going to compare the rules in GitLab to the one that's in our SIEM. It checks if any updates are required, creating new rules, creating a new version of a rule, if the logic has changed, and then enabling or disabling rules. So in this screenshot, you can see that new rule was created in our SIEM. It was enabled to run against our logs, and it's enabled for alerting as well. And then we get this summary that's printed out at the end of the job's run, and that's preserved. Yeah, so as I mentioned earlier, like many teams will kind of configure a job like this to run on a schedule, maybe once a day, to push out changes to their security tools if they want to overwrite anything that was done in the UI. Just to mention that as an option, right, if you're designing your own pipeline. All right, and then after that job completes, is push changes out to the SIEM. Our pull latest rules job runs again, and this pulls a fresh copy of all the rules from our SIEM and commits them back to the GitLab project. It might seem weird at first, but the reason this is done, it ensures our code base is kept up to date with what's in our SIEM. So, for instance, when we created that new rule, we didn't know the unique ID or revision timestamps. The SIEM decides that, right, when a new rule object is created. So we're syncing that back. And then, that process for kind of modifying a rule is not all that different from creating a new rule. So you've got your detection engineer stages their changes in a pull request in a new branch. They wait for those tests to pass. They get that peer review and approval. And then the changes are merged into the main branch and pushed out to the SIEM, right? So it's rinse, lather, repeat there. And then, a couple more benefits, really. So as we're working on our detection rules, kind of iteratively changing them, we're left with this audit trail that's left behind, right? So we've got, in our version control system, it provides that commit history for each rule, the context for each the changes preserved in those commit messages and the pull requests we've been working on. So people can easily kind of go back to review the previous state of a rule or figure out context and the reasons behind changes. And then, a few other benefits of kind of storing them in this centralized repo. You might have auditors that come in and ask if you have proof that you have a particular detection in place. So if you work in the financial services industry, auditor might ask if you've got detections in place around things like Swift or data loss prevention. And you can easily just show them those rules and you've got them in place and deployed in, say, GitHub in this example, without giving them access to your security tools, right, and potentially just leaving those permissions there. If you've got a purple teaming capability, you can give the offensive team access to review your rules, depending on the relationship between the red and blue team, and they can look for ways to kind of evade your rules in preparation of the next purple teaming exercise. And then finally, you've got this searchable code base, right? So all your rules, imagine from your SIM, EDR, next-gen firewall, all that kind of thing. You can quickly do a quick search if a new technique comes out and you're wondering what kind of coverage you have today with your rules. Yeah, a couple of key takeaways after implementing this at a couple of companies. So we've got, a few minutes left here. This is obviously subjective, but my opinion on what types of organizations can benefit from doing this. If you're a large organization with this complex, dynamic environment, lots of security data available, I think this kind of detection as code approach can help the team keep their coverage up to date and stay one step ahead of attackers. If you need that additional auditing and change management, it could be a good fit there. You might have a budget for dedicated detection engineers where they kind of assess, what coverage they have with the rules that vendors provide or what the teams develop today, and then, use threat intel kind of improve their detection coverage against threats over time. And then on the right, I don't need to read all these off because it's kind of the opposite of the left, but, if you're a small company, maybe no dedicated security team, probably not a good fit. You're probably going to be partnering with a managed security service provider who's doing detection as code anyway, right? Because they're probably managing the rules across multiple customers and environments. And some advantages we spoke about earlier, right? And my favorite reasons for doing this, that collaboration results in better rules for your organization. We've seen vendors sharing more detection logic over the last few years. I think this has helped organizations build a better defense against attacks. You've got more control over change to your detections. We spoke about that in detail. And then, with this automated testing, you can reduce the risk of deploying changes that break your detections. You could be alerted to issues with your monitoring and detection capabilities before anything goes undetected. And I can share these slides after. I think here are some links to some useful resources if you're interested in learning more about this or detection engineering in general. If you're looking for some tutorials on how to kind of build this in a lab or at work based on what you have, I've got one that works with Google SecOps, one that works with Sumo Logic. And again, at the bottom, if you're not familiar with these projects, you've got projects on GitHub with free detection rules to experiment with or see if you can use them at work to increase your coverage. So that's it, Thanks for coming. I think we've got a few minutes for questions.
So every new process is basically another attack vector or something. What's the gotcha for using this? Like, if you were to adopt this in your organization, what's something obviously the rules is a big thing, and if you have the peer review them, probably you have to go to hopefully something super fixed cost during that process. But is there something else like we need to be watching out for if we were to start some of this?
I think monitoring what people are doing in the UI, right?
Perhaps random detection for it.
Exactly. Do that. Monitor for that. I think obviously when you're using DevSecOps and CI/CD tools and all that, secrets management is going to be another big one. Might be obvious today, but you might have a security team who don't really come from like a software engineering background, so maybe they could partner with someone internally. Just trying to think what else.
I was thinking of like your tech computer or whatever it is actually running pipelines and stuff, obviously becoming very high risk. So there's something else that I'm not thinking about.
I think maybe controlling who has access to open pull requests, and then, I don't know, can someone inject something in your GitHub Actions workflows? I think, nothing else comes to mind at the moment. You could have the code owners file, right, and make sure that you might have certain parts of the security team that are fine to review rule changes and approve and push those. Yeah. Yeah, and then just have certain people on the team who can kind of review and approve code changes, right? And messing around with the API and running tests and that kind of thing. Yep.
So the testing you've got with it, was there like integration testing and things? Have you seen any unit testing margins or like testing rules in isolation?
Testing that they match on a log file, or
The testing of the functionality matches what you're actually coding for as part of the build process.
so
Like a sumo simulator or something. Yeah, well, like Angular or something, you were doing like Java code, where it tests the functionality as part of that build process, or is it standalone for you? Yeah. So it's like thinking if there's like a shit style test, if you're finding those issues before.
yeah, Elastic do that in the detection rules repo. Yeah, they've got, so if you're an engineer staging a rule, you provide that sample test data. Maybe you collected some events from your lab, and it will load up, I think like a pseudo detection engine, make sure the rule compiles and can run over that log data. So yeah, definitely possible. Yeah, I haven't read that code myself, but I've seen it done. Yeah. Yeah, you could. Yeah, best practice or stuff that I've seen at least. You could break in that rules directory. You could break your rules out by platform, and you could have your CI/CD jobs detect for changes in those different directories, and then pick up the rules from there and deploy them out to your respective tools, right? And I like to keep the rule config kind of separate, because especially if you're a vendor and you're managing it in multiple environments, it gives you that granular control of like what gets pushed where and what gets enabled versus disabled. Yeah, you can put like customer ID or the instance ID for your tool. Yeah. Let's see. Is that it? Last one? Okay. Oh, the requirements of a detection? Yeah, so something like, in the pull request template, you would use something like Palantir's alerting and detection strategy is a good one, where you, as the rule author, you specify like the name for the rule, description of what it should detect, no limitations, false positives, that kind of thing. So you'd fill that template out, and then when you request a review, the expectations that you can read that and understand what the rule's objectives, right? So you would do that. Yeah. Yeah, I've got to get off now, right? Yeah. Let's talk on the side. That's right. Sorry, I don't want to overrun into the next session. Thank you.